So in this video we are going to cover the following topics. First of all, we are going to discuss special matrices, and then we will discuss colon operator, and next and we will discuss how we access elements in the matrix and build-in functions in Octave. If I have time, I will discuss how we photograph using Octave, right? So special matrices in Octave. So suppose we want to find zero matrix, 2 by 2 zero matrix or 2 by 3 zero matrix. So you don't need to type out all entries by typing zeros, right? So you just use this command, the command zeros of the dimension of the matrix. So if you want to type a 2 by 2 zero matrix, then you should type zeros, the dimension of the matrix 2 comma 2. And then suppose you want to type you want to use a matrix whose elements are equal to 1. All elements in that matrix are equal to 1. Then you can use this short way, right? Just type ones of the dimension of the matrix, and the next one, if you want to use an identity matrix, the way you have to type is as follows. So E by E and the dimension of the matrix. So in this case the dimension is 3 by 2. Then you get a 3 by 2 identity matrix. So let's go back to Octave. Let me open Octave. Now we are in the command prompt, right? So let's clear screen by typing CLC. Now so let's generate a matrix A. It's say 3 by 3 matrix, but its elements, all elements in the matrix A are equal to 1. So you have to type ones of the dimension of the matrix. I want to type a 3 by 3 matrix. All entries are equal to 1. So here we go. So A is equal to this matrix, and let's input a matrix. So let's generate a matrix 3 by 3 of zeros. So you have to type zeros zeros and the dimension of the matrix, say 4 by 4. So we have the matrix 4 by 4 of zeros. Let's generate an identity matrix. 3 by 3 identity matrix. So this I is denoted by a 3 by 3 identity matrix. So I had to type E by E and give the dimensions. So 3 by, you don't need to, so if the number of rows and columns are equal, then you don't need to type twice, just type 3. This gives you an identity matrix, and there are 3 rows and 3 columns. So identity matrix, 3 rows and 3 columns. So you don't need to give 3 comma 3 because the number of rows and columns are equal to each other, right? And the next one, let's generate an n by m matrix of random numbers. So let's generate 3 by 4 matrix of random numbers. Then D is equal to random numbers and give the dimension 3 by 4, 3 comma 4. So here, so there are 3 rows and 4 columns. So these are random numbers. So these numbers are in between 0 and 1, right? So if you type that again, this time here random, these numbers are changed, because this is a random, so you get a random value between 0 and 1, right? So let's generate a row or column vector, right? So let's generate a column vector 1 2 3 4 5 6. Now using this you can generate a random matrix, not random, diagonal matrix. So whose diagonal is equal to this vector. So let's for that you need to type diag S. Here we have the diagonal matrix. In the diagonal you have these elements. Other elements are equal to 0, right? So now let's discuss colon operator and linspace operator. So the colon operator, so you can use the colon operator to define an ordered set. Firstly, we create a list of numbers from a starting point. This is the starting point, and this one is the increment, and this is the end point. So coming back to Octave, let's clear the screen. CLC. Alright, so let's do like this. A is a list of numbers starting from 1, and that and the end point is 5. So list of numbers starting from 1 to 5. 1 to increment, this one is, so the increment, if you don't specify the increment is 1 here. So here increment is 1. So if you define the increment, say 0.5, I want to increase increment of 0.5 starting from 1 to 5, but the increment is 0.5. Here this is the first element, second element, third one, fourth one, so the increment is 0.5. Alright, here you specified the increment, but this case you didn't specify the increment. If you don't specify the increment, Octave automatically takes the increment by 1, right? So in this case the increment is defined, so then you get a list of numbers between 1 and 5, but the increment of 0.5. I hope you understood this part. Colon operator, right? Now let's discuss the linspace. Here this is the command. So linspace, so first one is the starting point and the second one is the end point, and the 6 represents the number of intervals you want to split this into. Number of subintervals you want to split this interval. So if you type this one, 1 2 3 4 5, no, number of points, so you want to split this one, so here you get 1 2 3 4 5 6 points, and if you notice the spacing between two consecutive elements, the spacings are equal, right? Spacings are equal, right? So let's try another example. Let's type all points, the points, not points, between 1 and 5. I want to print 10 points between 1 and 5, including 1 and 5, right? Yeah. So first one is this. Here you don't give increment, they compute the increment, we just input the number of points we need. So we need 10 points in between 1 and 5, but the colon operator we used, I think you remember, so this is the starting point and the increment of 0.5, and the endpoint 5, then they give. So here we give the increment, but here we don't give increment, but we give the number of points we need in between 1 and 5, right? So this is the difference. So both methods produce vectors with equally spaced elements. Colon operator method allows you to specify the first element and space in between elements, but not the number of elements. But here in linspace method allows you to specify the first and the last elements of the vector, but not the spacing between elements. So this time you give the number of points you want to print out in between 0 and 10. So here you give this is the colon operator. Here you give the increment. This is the increment. So I need want to print numbers between 0 and 10 with the increment of 3, but here I want to print numbers between 0 and 10, and here I want to print 11 number of points in between these two numbers. Hope you understand colon operator and the linspace. So next we are going to discuss how we access elements in the matrix. So if you enter some kind of matrix, so coming back to our command prompt Octave, so let's type a matrix. Let's enter matrix, open up a square bracket, 1 2 3 4, and break the row by typing semicolon, and the next row, my next row is 5 6 8 4. Let's include another row. Right, this one. Alright, this is a 3 by 4 matrix. It has 3 rows and 4 columns. Right, let's say I want to access this element. So how do we do that? So the name of the matrix is A. So, and I want to access this one, the value of this entry. So this is located in the first row and the second column. First row and the second column. Enter this one. So the value of this entry is 2. So likewise you can access any element in the matrix, right? So if you type in this way, suppose I want to I want to print out the first row. So how do we do that? So I need to print first row and comma, put this colon operator. Alright, colon, then this gives me the first row of the matrix A, right? And similarly you can print any column. So A, and this time I need to print the third column. I need to print third column. So all row elements, and give me third column. It gives you the third column of matrix A. Likewise, you can access any row and any column or any element. Or let's say I need to print out this part only, the first this part here, right? How do we do that? So for that, so here we go. So I need from first row to second row here, from first row to second row, and I need from first column to second column. First column to second column, it gives this part. Likewise, you can access to any entry or any part of matrix or any column, any row, anything you can do, right? So now we are going to discuss some inbuilt function Octave has, right? There are many inbuilt functions, so I'll take some of them. So right, first one, let me show that. So these are some inbuilt functions Octave has. So absolute value, you can use abs to take the modulus, magnitude of a number, right? A cos is arc cosine, right, or inverse cosine in radian, and so many things you can let's say, wait a second, arcot, arcosh, what else? There are many inbuilt functions, and arctan, so yeah, degree. So if you put d in front of arctan 2, then you are dealing with degrees, so you have to type in degrees. Hyperbolic tan, arc hyperbolic tan, what else? So there are a ton of built-in functions, so you can browse that. So if you are interested in looking those inbuilt functions, so just go to this link here. So if you type this one, you can browse all built-in functions in Octave, right? So I use some of built-in functions. So here, if you suppose I use ceiling, let's type that one, ceiling of 3.5 number. So I think you know ceiling function. This rounds up to the nearest whole number, so the nearest the rounds up to the nearest whole number, which is 4, right? This gives you 4. And floor, the inbuilt function floor of this one, so this rounds down to the nearest whole number, which is 3, Okay. And if you round 3.5, you get 4. You can round, so this would be the nearest whole number. This will round to the nearest whole number. This will round up to the nearest whole number. This will round down to the nearest whole number, like that. So what else? And cosine of say pi, so just type pi, which is -1, and sine function, sine of pi, sine of pi is 0. This one is approximately equal to 0, right? This is it, right? This one is 0, nearly 0. And so if you want to convert this should be radian. You should keep this one in radian. So if you enter in degrees, you need to type sine d, say 45 degrees or 90 degrees, gives you 1. Cos degrees, the more these degrees, then enter cosine of, let's say 45, no 90. We know cos of 90 degrees is equal to 0. Right. An exponential function, exponential function of e to the power 1 is equal to 0.7183 something, right? So sometimes we want to convert degrees to radian, radian to degrees. Let's find that function. There is an inbuilt function for that. So this one is the built-in function, radian to degrees. So enter your radian value. So I want to convert this radian to degrees. Pi, when you enter pi, then you get degrees. That one is equal to this degrees. All right. So I will do another session, another video for plotting part, right? So I hope you understood the basic. I think we have covered what I mentioned earlier. So I will do another video for plotting part. I see you in next video.